the scientific EVM with the Ethereum data service. In previous videos, we showed you Tally, our arbitrary precision math library for integers, available as a smart contract written in Solidity. With Tally, you can execute mathematical operations on arbitrary large, unsigned integers. You can add them, or multiply them, or subtract them, divide them, etc. What we are doing today is integrating a Tally smart contract to interface with our Ethereum data service, or EDS. On-chain, we have two contracts, the EDS contract and the Tally contract. Using the EDS application, we can see the registered contracts under the EDS contract, and we see the Tally contract at this address. Contract type 1 means that we should expect a Solidity type interface encoding instead of the native EDS interface. And we can see all the functions from the Tally contract under the set that contains all the functions from the Solidity type contracts. In this case, the Tally contract. And you can recognize these functions from our previous example. So the EDS contract knows a lot of things about the Tally contract, its address, its functions, and the EVM computable form of the ABI for each function. It knows the types for each input and output. This dApp is the normal EDS database browser dApp, and we also have the decentralized function dfun dApp. This was demoed in a greater detail in a previous video. At a later date, the dfun will become a plugin of the EDS dApp. Here we can see again Tally as a linked contract. And all these functions are functions from the EDS contract. But we can see this add store and mul store functions, which are native to the EDS contract. They use the Tally contract in the background. So what these functions do is receive the set ID that will be used for the arguments. In our case, this will be the numbers set, which has an ID of 8. The numbers set has 4 records from keys 0 to 3. So we have set ID 8 and then 2 record IDs for the 2 inputs. Let's add value at index 0 with value at index 2, and then a record ID where the result should be stored, 4. This is a transaction. We do the transaction, we confirm, and then we also get a receipt, which contains some logs about the actions that happened in this transaction. But let's go to the EDS browser, and instead of refreshing the page, we can just add key 4 here. And we see the result of adding this value at index 0 with this value at index 2. This is the on-chain representation of a uint 128 array. Now let's try mul store. Again, we will use set ID 8, and now we will add value at index 3 with value at index, we will multiply value at index 3 with value at index 4 and store the result at index 5. We confirm the transaction, and then let's see what we get at index 5. So this is the result of multiplying these two values. And we can see it is a pretty large number. So what have I done here? I have created some functions in the EDS contract that retrieve values from the arbitrary large numbers set use tally to compute a result, and then insert the result in the same table, in the same set. So you have seen a demo of an on-chain database with calculations performed on a testnet. The database is dtypedb, and calculations are done with arbitrary length uint arithmetic, the tally library, and tally is the equivalent to what can be done with Python and Mathematica. And in the video we made about tally, we compared the results with Mathematica. Using the blockchain as a secure and transparent repository for high-precision scientific constants and variables. And of course, this system has all other advantages of the EDS system. You can expect more future demos on rational numbers, fixed and floating point numbers. What else was demoed here? EDS can interface with Solidity contracts through on-chain ABI storage by automated translation, forwarded execution from any EDS contract to Solidity contracts, interfacing on-chain with dtypedb, Solidity functions introspection, EDS functions introspection, casting of types to interface with the typed database, type-specific rendering by React.js to EDS output, and database wrapping of deep decentralized functions. Inputs come from the database, outputs are inserted into the database. This type of integration of a global on-chain database and different Solidity contracts can lead to important synergies on the EVM blockchain. This marks also the beginning of the scientific EVM.